Okay, so we're going to do some of these definitions here. First one we have, these are special segments of a triangle. The first one we have is a median. That is a segment of a triangle drawn from the vertex to the midpoint of the opposite side. So, FH, and this would be an example over here, segment FH is a median of triangle EFG because H is the midpoint of segment EG. All right, so FH here, that's the median of the triangle because it's drawn from a vertex and it splits the opposite side into two equal parts or two equal lengths. So let's do a little thinking with these. So how many medians can a single triangle have? That's 3. One of them is drawn in on this triangle to the right. How do you know how do you know that M is the midpoint? It's those markings on segment JM. I'll just say on the segments. Right, these guys here and here. Draw the other two medians and label the triangle accordingly. So if I go to another color, if I start at this vertex, I want to connect the midpoint of the opposite side. So the middle looks about right there. So if I draw on that segment, and then I'm going to label it with my tick marks, I know those two guys are going to be congruent. So there's one of the other ones. And remember, there's 3 in total. Now if I go from the vertex K and I find approximately the midpoint on JL, if I connect that segment and I mark those congruent, then I know it's the midpoint and therefore it's a median. So in example 1, in Scalene triangle DEF, EG is the median side to DF, DG is 12, x minus 6, and FG is 9x plus 30. Draw and label a diagram with all of the given information. So we got our triangle here. G is going to be that midpoint, so EG is the median. So I know these two segments are congruent. GD is what? 12x minus 6. FG is 9x plus 30. So there's the diagram drawn, so that's part A. Part B, find the value of x. So for part B, I can say since this is a median, I know that the segment GD is congruent to, or I should say it this way really, I know the measure of segment GD is equal to the measure of segment FG, so therefore I know 9x plus 30 must be equal to 12x minus 6. So I'm going to solve that for x. I get 3x equals 36, x equals 12. That is the answer for part B. Part C says find the length of DF. So DF is the entire side there. So I'm just going to find either DG or FG. So DG is equal to 12x minus 6. So I'll go 12 times 12 minus 6. And I get 138. That's just DG. I know that DF is going to be double that because that's half of it. So when I double the 138, I get the length of DF to be 276. So that's one special segment. It's called the median. The next special segment is called the altitude. And the altitude would be a segment of a triangle drawn from the vertex and perpendicular to the opposite side. So if we look over here, this segment here, AD, since it's perpendicular, if segment AD is an altitude of triangle ABC because segment AD is perpendicular to segment BC. All right, so let's look at working with this a little bit. So in the figure, DC is an altitude of ABC. What kind of angles do perpendicular lines form? Right angles. How do you know that DC is perpendicular to AB? The marking. It's a right angle box, I'll call it. All right, this guy right there. How many altitudes does triangle ABC have? It will have 3 because I can draw one from each vertex. So if we want to draw the other ones, I have to start at a vertex. So I'll start at A. And if I have to go perpendicular to BC, it looks like it's maybe right along that side. So it could be slightly less, maybe like that. It could always be one of the sides of the triangle. That could work out. So there's one of them. Then the other one, if I started at B, again, it sort of looks the same. But this one looks like maybe it would go outside the side a little bit. So it would be like right there. And typically what we do is we just kind of do a dotted line there to show that it extends out. So that would be those altitudes. Let's look at a couple of these questions here. OQ is a median and an altitude of triangle POM. So they want us to draw and label a figure to illustrate this. So I've got a triangle POM, and then PQ is a median and an altitude. Well, median means it starts at P, since it's PQ. It's going to cut the other side in half. So there's the midpoint of the other side. When I draw it in, that makes it a median. What would make it an altitude if it was also perpendicular? So there we go. I drew that. AC and BC are altitudes of triangle ABC. What type of triangle is this? So when I draw my triangle, it's got to be a right triangle because triangle ABC, the altitudes are actually sides of the triangle, right? A and C and B, AC and BC themselves. So when I draw it, it's got to be a right triangle. And so that's why. When the sides are actually when one of the sides or two of the sides are the altitudes, then it's a right triangle.